We are Team 9, and our project is the hurdy-gurdy. Our team members are Brody Brooks, Nate Pitts, Andrew Miller, and Joey Bell. First up is our problem and background. So as you can see from this screen, we have a picture of the traditional hurdy-gurdy. It is an instrument popularized during the Renaissance. It is a crank instrument with drone and melody strings that is played through pressing keys and cranking the instrument. What do we plan to fix with this? We plan to add MIDI interfacing to allow the hurdy-gurdy for DAW capabilities. We want to digitize a mechanical process, that being the traditional instrument. We also plan to use a digital process to add precision and accuracy to the traditional instrument. Why do we plan to do this? We want to create an augmented instrument, that being the hurdy-gurdy. It is not something that has really been done yet before and has only been done a few times, and we want to create an instrument that will meet the needs of people seeking a digitized musical instrument. So our goal is to digitally augment the hurdy-gurdy. We have a $2,000 budget, and we want to overall create a MIDI instrument that is able to track the crank rotation and push button presses. The crank rotation will adjust the volume, and the push button presses will simply play notes. We want it to be able to act as an input to a digital audio workstation or DAW. This project will be completed in 6 gates. We have already completed gates 1 through 3 during spring of 2024. Gates 4 through 6 will be completed in fall of 2024. We have currently already completed gate 4. This will include initial prototyping, conclusions, and final test planning, partial test results and design documentation, and then the project finalization.
The next slide is focused on the state of the art for the hurdy-gurdy. There are many different routes that we could have gone with this design. Other versions of an electrical hurdy-gurdy have already been created, but they don't achieve the exact same goals as ours do. Some other examples of previous ones that we got inspiration from include the digi-gurdy and the hyper hurdy-gurdy. For the digi-gurdy, it has DAW capabilities and MIDI output, but it does not function as a traditional instrument. There's no strings or anything like that in it. And the hyper hurdy-gurdy functions as a traditional instrument, but there's no DAW connectivity, so you don't have the option to adjust the volume digitally or change the actual output of the sound. And for our design, we decided to have DAW capabilities and a MIDI output, so we can have the ability to hook it up to any type of digital audio workstation and pretty much have it function like any other MIDI instrument that you would normally use. Um, Another option that we went with was the shape of it. Instead of just having it a regular box, we wanted it to um, look like a traditional hurdy-gurdy as well, which you can see with the design on the right-hand side of the screen. And our option is also much more affordable than others.
So for our system solution, first we have our current electrical design, and in this we have our rotary encoder on the right side, and then the left side we have our 6 limit switches and 6 pull-up resistors. Now in our final product we are going to have 14 limit switches, which will include 2 additional buttons, which is the octave up and octave down buttons. Okay, so our first part, as we can see here, is the neck, which the neck includes the 14 buttons. And then our second is the lever arm, which is shown here. And we also have the handle, which is our 4th part. And then the 5th part is the buttons. And then the 6th part would be our bottom, which hooks up onto the body.
Now for a quick demonstration of the instrument. The prototype that we have on the table is 6 buttons with the pull-up resistors going to different digital inputs on the instrument. And then we have a crank that is currently connected to the rotary encoder. When we start spinning that crank, you can see we start to get the drone strings activating in our audio workstation here. You can see that with the slider moving up and down. And then while the crank is spinning and we press onto one of the buttons, it starts to actually play one of the notes, and the volume changes with how fast the crank is moving. And then if the crank is not rotating and a button is pressed, just like the real stringed instrument, we're not getting any kind of volume coming out.